And the next topic we're going to cover in class here is what is known as nested for loops. What nested for loops are, and nested loops in general, are loops within loops. So in order for one loop to break, another loop's condition has to be met. So in the graphical example you're going to see, I'm going to take a for loop, set it to integer I equals, I would set it to 1 as the start position. And we're going to have the loop end when I is no longer less than 11. It's going to increase by 1 each time. Very good. Now, with that in mind, if we were doing what we're used to right now, or getting used to, our for loop would end right there. So this is ending our I for loop. Now, this is forception, or with if statements, nested if statements, ifception. If you've seen the movie Inception, you know what I'm talking about. A dream within a dream. This is a loop within a loop. So, we're going to create a second for loop, integer, and now we have to give it a different letter, j, and we're going to do the exact same thing, make it equal to 1. Make it where j, this loop continues until j is no longer less than 11, and increase j by 1. Notice how, if I bring it back, the for loop's brace for j ends within I. So in order for I to end, j has to end as well. So I'm working with the interior for loop of I, or the interior for loop of j, and the exterior for loop of I. So I'm about to show you how this process moves forward with the different loops. Here I have my for loop racetrack, or nested loop racetrack. So I have my piece for I, which I'm going to put right up here, and I have my piece for j that I put up here. So right now both are in the one position. What has to happen with nested loops is that the inner loop has to get through an entire cycle before the outer loop can move on to its next position. So if you think back to our other slide, both started at 1. So before I can go to 2, j has to make its way around through all of its criteria, and then it will start at 1 again, and the I now will start at 2. And j makes its way around again, going through its entire loop cycle till it starts at 1 again, and the I's at 3. Another way to think about this would be with a clock. How the second hand has to make it around the whole time before the minute hand can advance. That would mean that the minute hand would be the outer loop, and the second hand would be the inner loop. So you're seeing I'm going through the same process. J gets through its entire loop cycle, so I can increase again. And yes, I am going to go the entire way around, because it's important to see that for this entire loop to be completed, j will complete itself 10 times. Sometimes a little bit smoother than others if I'm in control here. And then one final cycle. When I reaches its final cycle, then j will reach there. J's loop is now broken after the 10th one, and I no longer has anywhere to go, so its loop is broken. So, that is the basic concept behind nested for loops. The inner loop has to make its whole way through a cycle before the outer loop gets to do its next thing. So this is what we're going to practice next within the class.